Hi, welcome to In 5 Minutes. Next we have a design of JFET biasing. What is given in the question? First we need to find the which type of JFET it is, N channel or P channel. So arrow again from P to N. When it is forward bias, current will flow from positive terminal to negative terminal. So arrow indicates the flow of current when it is forward bias. That means right hand side you have N, so it is N channel JFET. Which type of biasing? You can call it as self biasing. No voltage in the gate and this voltage across RS provides the biasing to VGS. So it is self biasing. Question tells, for the network shown in the figure, levels of VDQ and IDQ are specified. They have given us the value of VDQ and IDQ, that is 12 volts and 2.5 milliamperes respectively. Determine RD and RS. They have told us to design the circuit. We need to find the value of RD and RS, and the standard values we need to assume, closest standard values. Now when you look at the diagram, when I am applying KVL in this part of the circuit, positive current is flowing from higher potential to lower potential. Here you have VD 12 volts, that is positive and negative. This type of supply is there over here. Here you have negative positive, that is we are living with a positive sign. So when you apply KVL in this loop, you can see KVL to output loop. What will be the equation? We are living with positive sign, so 20. We are living with negative sign, so minus IDQ into RD. We are living with a negative sign, so minus VD equals to 0. So I can find RD from this as 20 minus 12 divided by IDQ given is 2.5 into 10 raised to minus 3. So I have got RD as 3.2k. right? Now we can plot the transfer characteristics. IDSS is given as 6 milliampere, VP is given as minus 3. So you know how to plot the transfer characteristics. We take 2 points, VP by 2, for that IDSS by 4 we get, this is 1, and second, for IDSS by 2 you will get 0.3 times of VP. That will help us to plot the transfer characteristics. Once the transfer characteristics is plotted, IDQ in the question is given as 2.5 milliampere. So what we can do, we can draw a horizontal line parallel to x-axis. Wherever it intersects the transfer characteristics, that is your Q point. So corresponding x-axis point is your VGSQ. This is how we find VGSQ. Now when you look at the diagram, what is VGS? When you apply KVL, your equation will be minus VGS minus VRS is equal to 0. That means VGS is minus VRS, and what is VRS? We can say VRS is minus ID into RS. So this equation I am going to use over here, that is VGS equals to minus ID into RS. Now what will be your RS? Minus VGS upon IDQ. Your value of VGSQ is minus 1, so minus of minus 1 divided by 2.5 into 10 raised to minus 3. This will give you RS as 0.4 kilo. Now the question tells us to write the nearest commercial values, nearest standard commercial values of the resistances. Now we have got one of the resistance as RS as 0.4k, and we have got RD as 3.2 kilo ohms. So nearest standard of 0.4 is 0.39 kilo ohms, and nearest standard of 3.2 is 3.3 kilo ohms. This is how we have designed the self bias circuit for JFET biasing. Thank you for watching In 5 Minutes.